What's up, guys? So this is a quick SQL syntax crash course to kind of just go over some of the terminologies and how to communicate with the database in SQL. So we're here in PostSQL, and here we have a database called employees. And if we scroll down, we're going to have four tables that we're working with. And so here you can see we have departments, department employees, we have the employees, and then we have salary. So these four different departments all have different columns as well. And that's what we're going to use in our syntax to communicate and do some data manipulation here. So we'll get into it and you'll see what I mean. But essentially, the syntax in SQL is divided into various categories. One of them is keywords. And these keywords basically are reserved words that have a special meaning. So you can't really use them as a variable. You want to make sure that you avoid these words and use them for the purpose that they're designed for. There's also something called clauses. And what they do is define the structure of a query. And we'll get into that. One of the ones that we're going to use a lot is called select. And then we have operators, and these basically perform things like arithmetic, logic, they perform comparisons, your typical equal signs, less than, greater than, and all that. And we'll get into those. And we have something called set operators. These combine the result of two or more select queries into a select result. Okay, so the two ones that we're going to be using is union and all. And then we have aggregate functions. Okay, and so they typically, like your count, they perform a calculation, so they give you a single value at the end to kind of count things or get a particular value out of the data. And that's basically what most of the terminology, the syntax is divided into. So let's get right into it, and we'll start with our first example. So each of these examples you're going to see is requesting a particular action to be done. We're going to have the SQL code underneath it. So it makes it easy to follow along. So first thing we're going to do is we're going to retrieve all the data from the employees table. So the employees table is right here. If we open up the employees table, we're going to see two columns. Six columns. And these are all the different columns that are in the employees table. Now we were asked to retrieve all the data from the employees table. So we're going to use the star, we're going to use select, and we're going to use star, and then we're going to say from employees table. So the way you read this is select all from employees. And that's the way to kind of structure this query. Okay. The next one is retrieve all data from departments table. So again, we're going to say select and star, and then from departments, and we go to the departments. That's your departments table. And the next one is retrieve all data from the depth employee table. Same thing. Again, we're going to use star, as you can see here. And then finally, same thing again, just to repeat. We have the salaries, all the data from the salaries table. Okay, so that was pretty easy. Just to kind of get some familiarity with the select syntax. And remember, select and from, they are basically, as we saw over here, they're called clauses. They define the structure of a query. Okay. So moving on, we have here, the next one is select the first and last name of all employees. Now we're getting a little more in depth in terms of getting more fine-tuned and trying to pick the specific type of columns out of these tables. So here we have the employees table, and then we have the first name and the last name columns. So we're going to do select first name, comma, last name from employees. And that's basically the way to read this is we're selecting the first and last name from the employees table. Okay, moving on to compare, select all records from employees. If you saw, this is the difference between selecting a specific column versus selecting all. Okay. Same goes for the department number, which we're calling depth number. Okay. So from the departments table, we have a column called depth number, and we're selecting that. Okay. Moving along, this was just to demonstrate that the difference between this and this. Okay, next one, select all employees whose first name is Elvis. Okay, so we're going to select all because we're asked for all of them, employees. And this is where another one of these, so over here, clauses come in, which is where. Okay, going back. So here it is, select all from employees where first name equals to Elvis. One thing to keep in mind is that if we're looking for text, you have to put brackets, single quote brackets around it. If we are using numbers, which we'll see in a second, we don't need to put the comma. And another thing that's very important is to have the semicolon at the end of all your queries to indicate that this is the end of a query. And as we're kind of getting more things here right now, I want to also mention the structure of how you should lay out your query, just so that it's readable. I could essentially put this up here and it wouldn't make a difference, but it just makes it a little bit more easier to read and more organized to have your code organized this way. Okay, and as more lines come in, you'll see. So it just makes it easier for someone reading. I can just say select all from employees where the first name is equal to Elvis. Okay, this is that one operator that we saw earlier. Operators, that's the equal sign, we're using it here. Okay, and the same thing, we're just changing the name here to Hillary. Okay, moving on. Now we're going to get into a little more in depth with the operators. So you select all. Okay, select all because star means all. Male employees whose first name is Dennis. Okay, so this is where we're going to use the AND operator. Okay, and because in this case, we're looking for all males and male employees whose also their name is Dennis. So we need to account for both these criteria to be true. So we can select all from employees where first name is equal to Dennis and the gender equals to male. Again, because it is a string, we're gonna put it in quotes. And same thing as this, it's a string, we're gonna put in quotes. Here we are, the next one, select female employees whose last name is Reistad. So here we are, select all from employees where last name is equal to Reistad and gender equals to female. So see how that's structured? Moving on, select all employees whose first name is Dennis or Elvis. So this is very important because you can't have both, right? So we're going to be definitely thinking about the or operator here. And as we can see here, we have or. So we have Dennis or Elvis going on here. Same thing, same way we started, except we're just using the or operator. Now, sometimes you might be looking at, there's another way to write this first part when you're looking at two different names, for instance. Let's say you have a lot of names. So maybe it's like 10 names. This is where the in comes in. We're going to use this clause called in. And so in basically tells us what any of these names, I make a list of all of them. So basically you want to say, it's almost like saying include. So the way you want to read this is select all from employees where first name includes Kelly, Aruna, and if you had more, you could put more here. Okay, so this is another way to kind of do that. Moving on, retrieve a list of all males and female employees whose last name is Dennis. So select all from employees because we're selecting from the employees table where the last name is equal to Dennis. Okay, pretty straightforward. Retrieve all lists of female employees whose first name is either Kelly or Aruna. Now, we have to consider something here. We need to make sure that it's female, and we need to make sure that these two names are the criteria that we need to search through. So what we can do is first start with saying employees where the gender is equal to female, okay, and the first name includes Kelly or Aruna. That's the way to read it. Now I could put this on the other side, so flip these two around the end, and it'll still be the same. Okay. The next thing is retrieve a list of all employees whose first name is either Kathy, Mark. This is what I was talking about earlier. So you have 3 names now. Instead of writing out what we did here, first name is equal to Dennis, or first name is equal to Ellie. And write it because they might have like a lot of names. You can just use this bracket notation using the in clause. Okay, moving on, we have these so-called wildcard characters. Okay, like the percent sign. What does that do? Well, let's say you're trying to extract a list of all employees whose first name starts with Mar. Okay, so we have so many names that start with Mar. Like we have Mark, we have Marge, right? So we want to select all because we're asked for all from employees where the first name, like, so this is where this clause comes in, Mar percentage. So the percentage sign says that anything after this is basically okay. So it needs to start with MR and then whatever that comes after it. So all the listed names are going to be starting with Mar, and it doesn't matter what characters come out after it, is going to be listed. Okay. And then similarly, we have extract a list of all employees whose first name starts with AR, and then we have the same thing here. Now, one thing to mention is that, which I didn't mention earlier, the capitalization is something that's actually ignored in SQL. So if I were to put AR here, it still would be the same. It wouldn't make a difference. So just keep in mind is that. And similarly, things like from, where, I could use lowercase, but it just makes it much easier to read and recognize that we're using, for instance, specific syntax. And so from that point of view, it's just best to make sure that we capitalize these types of syntaxes so that we can be able to better understand what the code is saying and doesn't look like too jumbled up. So things like operators, things like clauses, we tend to make sure that we capitalize where it's needed. Even all kinds of areas where it has a meaning behind a query. Okay. So what do we do? So next one, we're going to move on here. What do you think the result of this query will look like? So we'll look at this. We also have this underscore. So underscore basically focuses on one extra character. So in this case, Mark, it will only return names that have Mark with one other character left beside it. Okay, not the other ones. So that's where example like something like Mark would be returned. If this name had more letters, like let's say it was Marcuni, let's say, for instance, so this name would not be the return. It's only names with one more character after it. Okay, moving on. What do you think this will look like? Similarly, because each of these underscores are one characters, this will return a name with 2 characters after it. Okay. What about this? We have this select all from employees where the first name, like, so we have 2 percentage signs. So what does that mean? It means that the name doesn't matter what's before and after, as long as it has the word M-A-R, Mar, has that phrase inside it, it'll get returned. So it doesn't matter what's before and what's after. Okay. And then from employees where first name, like, so this like is very important. Like, in this case, this Mark is when the individual's first name starts with Mark. Okay. That's what that means. Next one, extract all individuals whose first name does not contain Jack. You don't want the name to contain Jack. And this is where not like clause comes into play, because not like is, sorry, this is an operator. Not like operator make sure that we don't include this. This name Jack, this for you can call it this phrase Jack. Whatever's before, you cannot have a name that includes that. Okay. Moving on. Extract a list of all employees who were employed between January 1st, 1990 and January 1st, 2000. Okay. So this is where the operator between comes into play. Select all, because we're asked all from employees. Okay, as you can see here, where the hire date, you can see the hire date is a column, is between this date and this date. Pretty straightforward. And then we have extract a list of all employees who were not employed between January 1st, 1990 and January 1st, 2000. So we're looking now for not employed. So because this not is here, we're going to use this not operator. Okay. Very common in programming languages. Select all records from the salaries table regarding the contracts from this. So now we're looking at numbers. As I mentioned earlier, if we're working with numbers, we don't need to put quotes around it. So just something to keep in mind. Basically, everything else is the same. Retrieve a list of individuals whose employee number is not between this and this. So I'm saying employee number, but really emp number is the name of the column. So we're asking this particular column is, we want the individuals who they're not between this and this, their employee number. And again, the not operator comes into play and we're using no quotes. Extract a list of employees whose first name is not null. Okay, so now we want the first name. So we're going to select all employees where the first name is not null. Null basically means that it doesn't exist. There's no value. Okay, so in this case, because it's not null, we want all the ones that have a value in that on that row related to that column. Okay, in this case, we're looking at the first name column. If there is null, we're going to want to maybe return it and see what those particular employees. So here's your extract list of employees whose first name is null. And this, in this case, we're using is null. Okay. Select the names of all departments whose department number is not null. Same idea again. We're just changing the column name. Department number is not null. Okay. And this again is null and is not is the operator in this case that we're working with. Okay. Moving on to other comparison operators. Okay. We talked about a little bit earlier that operators tends to be used to compare things as well. So retrieve a list of all employees whose first name is Mark. So select all employees where first name goes to Mark. Pretty straightforward. Retrieve a list of all employees whose first name is not Mark. So here we are. We have this operator. And remember, we could replace this with also exclamation mark equal to. This would essentially return the exact same thing as well. Okay. The greater than or less than is also very useful. In this case, we're returning all the employees who's employed after this date. And so we use in the greater than. So select all from employees where hire date is greater than this date. Similarly, if you want to look at it's employed on or after. So we're including this date as well. We're going to put greater than or equal to. Okay. In the same idea, less than this date or less than or equal to. Okay. Here we have retrieve a list of all female employees who were hired on or after January. So now we have two criteria. We have it has to be female and also hired on. So that's where we're combining. Select all, we're asked for all from employees because we're asked for the employees table where the gender is equal to female. Don't forget the quotes because it is a string, and using the and over here the and then hire date greater than or equal to this date. Okay, now extract a list of employees whose salaries higher than $50,000 per year. This one's pretty straightforward. Just salary greater than $50,000. Okay. Now, there's also things like distinct, which is really interesting because if you want very specific value, so here we go. Select distinct gender from an employees table. This is those particular keywords that essentially what they do is they give you a particular value that you want. So we're looking for how many genders are basically you know, referenced in this table. So select distinct gender from it. So this is so in the distinct situation, you're going to write distinct and then gender from employees. And essentially, if you wanted to bring this down over here just to make it more readable, but that's how you distinct always goes over here. So select distinct first name from employees. Another one. So in this case, we're looking at distinct first name. We want first names that are not we want to know how many like of this of a distinct first name. It's pretty straightforward, right? Extract a list of employees salaries higher than $50,000 per year and sort by the most paid employee. All right, so this is where it gets a little bit interesting. Select all employee basically. Now we're not going into the employees table, we're going into salaries table. So let's look at the salaries table real quick. So salaries table has these columns: employee number, salary from date to date. So we're going to take the salary from the salaries where salaries greater than 50,000, and then because we're doing a sort, this is where the order by comes into play. The order by is a way to basically descend or ascend the way the data is provided to you. If I don't put anything here, let's say, it's automatically ascending order. Okay. In order to make it descending, we need to put DESC there. Okay. Now, the next one is select all records of employee table and ordered by the first name. Select all from order by first name. Okay. And we actually forgot semicolon here. Make sure you always put that. Next one, select all records employees table. Oh, we just did that. Select all records and order by first name in descending order. As I mentioned, descending, we just have to put this term descending. Select all records and order by first name and last name in ascending order. Now we have employees' first name and last name. So here we are from employees, order by first name and last name. Okay. Retrieve a list of the first 100 records in an employee table and order by employee number ascending. Okay. So we're going to select all from the employees. We're going to order by the employee number, okay, because we have that in the employees table, employee number. And then we're going to limit it, and this is where this phrase comes into play, limit 100 records. I'm going to put 100 here, okay. And then here we have count how many first names are in the employee table and rename the result as first name count. So many times you don't want the output to just give you the column name. You want to define the column name yourself. So this is where the as syntax comes into play. The as basically says that I want the value, but I want you to name it as this. So I'm actually going to run this because I think it's good to see how this looks. So if I didn't do this, I'll bring this down here to make it. If I didn't do this, let's see how that would look. And delete this. So it's just going to say count. But because I give it a name, now it becomes this particular name that we put. Okay. So to count something, you use this aggregate function, and then you put the name of the column inside it. So in this case, first name. So now we're going to talk about joins and unions, which are basically a way to extract information from two or more database tables inside a database so we can get some values. And sometimes information that resources columns that exist in one table also exist in another table. And when that's the case, then these two tables can actually in some ways can be combined on based on this one column that they have in common to give us values that otherwise don't exist in either column by themselves. And I'll show you in a second what that means. So in this case, we have a task to write a query using inner join, which is one of the joins we're going to talk about right now, to list all employees along with the departments they belong to. So we want all the employees and departments they belong to. Okay. Let's look at our tables. We have departments, we have department emp, so department employees, we have employees, and we have salaries. So we don't need to worry about the salaries because we're not working with salaries, but we are going to be working with these three tables because the information that we want is to connect employees with departments and extract and connect, find out what employees are in which department. The issue is right now is that the columns that are in employees, none of them match the columns that are in the departments. And in order for us to be able to connect these two, join these two, we need to use the depth EMP table because this table has employee number and this table has employee number column. And because they do, we can join these two, and then from there we can then join over to the departments because departments has department number and depth EMP has a department number as well. So this is how we're going to be able to then connect these two. So as you can see here, we have a query written. Before I start, I want to mention something about aliases. A lot of times it might take too long to write out different table names. So what we can do is use something called an alias, which is something that you can define whatever it can be. And then what we can do is just define that so that every time we reference this table, we can just use this alias. So in this case, we're just using E. Everywhere I use E is the same as me just saying employee, okay? So we have select E.employee number. We are selecting this column. We're selecting first name with the last name, and we're also department number and department name, but we do need to reference where those columns come from. So in this case, we use E because this comes from the employee table. This comes from the employee table. This comes from the employee table. This comes from D, which we've defined as the departments table. Okay. So this is what we're interested in. We're going to take it from employees, and we're going to first join, as I mentioned earlier, the department EMP, and we're going to join on something they have in common, which is EMP number and EMP number here. So these two exist in both these tables. So we're going to join on that, and that's why we use this syntax. Once we get this value, we're going to continue on to join onto the departments, and then we're going to join based on department number, okay? Because these are two things that are in common between these two. And so when we join on those, we're able to get an outcome, which I'll show you in a second, where we get to have department name referencing what employees. So we get to know what employees work in different departments. Okay, so that's how basically joins works. Now, let's say you want a list of all the employees and their departments, but you want to include also employees with no departments. So in this case, we do is we use a left joint. Okay, a left joint in this case is the same idea as this, except we just put left. And just to mention, we could even just use join. We don't even have to put inner in this situation, because if you did just saying join, it automatically means inner. So in this case, we're using left join. And what that does, as I mentioned again, it gives you, this gives you when there is a match, this gives you when there's a match also, but it also includes employees with no departments. That's in case sometimes you want to look for that. And let's say you want now a list of all the departments and the employees in them, but you also want to include departments with no employees inside them. That's when you use a right joint. The reason it is left is because it's basically returning everything from the left table plus the matching rows on the right table. Okay, so this is the left table, this is the right table. We're referencing employees, the left table. And because we had to use two joins, as you can see, this happens twice. But essentially, that's what left and right means. And in this case, this is the opposite. We are returning all the rows from the right table plus the matching rows from the left table. Okay? And a self join is basically you want to list, let's say you want to list all the employees along with their managers. Let's say that's what you want to do. And all that information is inside one table. So you're not joining another table, you're joining to itself. And basically, we don't have this particular criteria in our table here, but let's assume that we have another column here called manager ID column. And it has a series of IDs there, and it's referencing anyone who is a manager essentially would get this particular ID. If they're not a manager, they would get the null beside their name. Okay, so that's what. So essentially, what we do here is we're gonna select our column that we're interested in. So we're gonna select employee number, and this as what that does is it makes the name of the table that we are going to create as the name of the column as this. So it just makes it easier to differentiate. Because we're using the same table, we want to differentiate when we're referencing employee ID or manager ID, because essentially there might be some overlap here. So we're going to make sure that we reference it. And then we're going to say from employees, join employees. And very important to use aliases that have they're not special characters. So we're going to say MA here just to be safe. Okay. Here too. So we're going to join these two, and we're going to join them based on manager ID and employee number, because obviously these both exist in the same table. And at the end, we're going to be able to get a table that shows us the employees table with a list of each employee along with their manager, each employee along with their manager. Now, so that's what joins are. Okay. Next thing is unions. Unions basically is a way to combine. Let's say you want to combine employee first names with all the manager first names and remove any duplicates. Okay. That's what essentially does. In our task here, we're going to write a query using union to combine a list of all employees' first names with a list of all managers with their first names. Okay, and what union looks like is like this. You're going to select the first name from employees. You're going to use union, select the first name from employees again, because and then we're going to give it an alias E, and then we're going to join it to department manager, which essentially would be the name of the table that we're using this union on. And then we're using employee E right here, and then department manager, and we're using this as a way of trying to create that union. Okay. Next one is union all. The only difference between union and union all is that the union all keeps all the duplicates versus the union just gives you sort of no duplicates. So you want to make sure you want to understand if you're looking to remove the duplicates or keep the duplicates. Thanks for watching, and I'll see you next time.